So if you look at the traditional column, right? Windows XP. So I got all these applications running. Microsoft IT comes in and says, you need to run this background.
Notice Outlook Express takes 3 tips as much memory as Photoshop.
The way that XP manages memory, it doesn't look at what's the least used. It looks at what's the oldest in memory. So the first thing I started that morning was Word. So Word's the first to go. So Word goes, background application comes in. Right? Idle text. Outlook goes, Internet Explorer goes. All that memory is gone. Right? Keep in mind, when I come back from lunch, the last thing in memory isn't, and in cache, isn't Internet Explorer or Outlook or Word. It's all these idle tasks. And by the way, I'm not going to run these after lunch. I actually want to get back to work. I want to run Explorer. I want to run Outlook. I want to run Word. So Superfetch pays attention to this. So I go to lunch, idle tasks say it's time to run. Superfetch looks at not what's the oldest in memory, but what's the least important. We need to close something. What's it going to be? So Internet Explorer is the application based on my usage. It's what's the least important. So that's the chunk of memory that Superfetch gives up. It only gives up that one chunk. Idle tasks running here. The idle tasks are finished. Superfetch knows that when I come back from lunch, I don't want to run the idle tasks. Idle tasks are done. I don't need to run. I need to run Internet Explorer. Superfetch reloads that back into memory for me. So Superfetch, efficient. It uses low priority I/O for prefetching and prepopulation, which means something else needs to happen. It's not tying up the disk at 100%. It manages both RAM and cache memory. One of the questions that I usually get is, so Superfetch pays attention to what applications I'm loading. Not really. It actually works with a 4K page load, pulling small chunks of data. I use whole applications to talk tonight just because it makes more sense to me. But it actually looks at what DLLs are used, not at full applications. Feel free to interrupt me if you have questions, by the way. So that's one part of the problem, right? We're using our memory smarter. The next problem is how do we avoid this bottleneck? So John mentioned something called ReadyBoost. So ReadyBoost enables me take my memory stick, plug it in, and extend my cache memory. External USB keys, SD cards, compact flash cards, internal PCI cards, all those work as a ReadyBoost drive. Under Vista, you plug it in, it comes up and says, hey, you've installed this thumb drive. Do you want to A, open it to browse files, or B, use it as a ReadyBoost drive? It gives you that option to do it. And it scales based on what you're using. So if you need to copy files over to that, it's okay. It decreases the amount of space used by ReadyBoost. It still enables you to use it for file storage. The goal here is to avoid the disk, right? Flash memory is up to 10 times faster than disk. Disk is about 10 milliseconds. Flash is somewhat 10 times faster. So the way ReadyBoost works is when I'm paging stuff back to disk, it mirrors it on the ReadyBoost drive, mirrors it on flash. So there's no unique contents on that drive at any given time. So if I were to unplug it from my machine doesn't crash, it just simply gets slower. So it mirrors the data that you're writing back to the drive on your ReadyBoost stick. It's secure. So memory keys walk. Right? I've lost one or two in my time. I'm sure everybody's lost a few. Memory keys walk. In the event that it does walk, the data on it is encrypted AES 128. More importantly, it's efficient. Right? It compresses data factor of about 2.0. So 1 gig USB memory stick becomes 2 gigs of cache memory. So this is a typical hard drive, right? You get DLLs on here, scheduled throughout. Something new called Ready drives. So Ready drives are designed for the mobile market. That's where you've got a piece of non-volatile cache actually built onto the disk. So it's utilizing ReadyBoost. It's utilizing ReadyBoost in the same way that if you put your USB memory stick in, it's cache writes with boot in the zoom sectors. So it's designed for state transition. So when I walk, my laptop lid closes probably 30 times a day, especially if I'm out on a customer site. Every time those boot and resume sectors are put onto the cache, not onto the disk. So when I flip my lid back up, the state transitions happen much quicker. So there's some ready drive benefits, right? Faster boot, faster hibernate and resume. That's the key point.